Good morning, 6th grade. We are going to go ahead and get started on the next section of this chapter. It's called Using the Pythagorean Theorem, but really what we're going to be doing is instead of finding the measurement of the hypotenuse, today we're going to be finding the measurement of a missing leg. So, I just want to bring back to mind what we're dealing with here. So, I should have made that a little longer. Go ahead and draw a right triangle. Should look something like this, and I'm going to mark where my right angle is. Now remember, when you have a right triangle, your hypotenuse is always opposite the right angle. So we always call our hypotenuse C, and our legs, doesn't matter which you call, but one of them is A, and one of them is B. And remember, our Pythagorean theorem looks like this. If I square both of the legs and add them together, that will equal the hypotenuse squared. Okay, so when we did the last section, I'm just going to flip back real quick. Here's our second example. When we did this one, we were finding our missing C piece, our hypotenuse. Today, we're going to be finding either A or B. So it's going to work a little bit differently, but we still use the Pythagorean theorem the same way. So I'm going to hop down here and put a number 1. Okay, and I'm going to go ahead and draw a right triangle. It doesn't need to be exact. Use the lines of your book to help you. Go right along that. That's a pretty good right triangle. And these are not drawn to scale. So don't worry about it being, exactly precise. So let's do this. I'm going to measure this as 15 centimeters. This will be 9 centimeters. And this one we don't know. Okay, so I need to find this missing piece. I know that this here is my hypotenuse. This has to be my C value because it's opposite the right angle. And these two must be my legs. It doesn't matter what you want to call A, what you want to call B. It's totally up to you. But I'm going to call this side A, and I'll call this side B. Okay? Excuse me. Now that they're all labeled, I can go ahead and use the Pythagorean theorem to figure out what this missing piece is. So I'm just going to do it right off to the side here. And the first thing I do is I always rewrite the theorem. Okay, just like that. So A squared is going to be 9 squared. I will solve that in a minute. I just like to plug in all of my values so I can see what I have and what I need. B, I don't know yet, so I'm just going to rewrite it as B squared. And this would be 15 squared. Okay, so let's go ahead and solve these. 9 squared is 9 times 9, so that's 81. Don't know B squared yet. And if you need to, go ahead and plug in 15 squared into a calculator, or you can do 15 times 15 off to the side, which is what I'm going to do. Okay, so that's 225. All right, now, in order to solve this, I need to get B all by itself on one side of the equal sign. So, ask yourself, if I need to get B alone, what needs to go? The first thing that needs to go is 81. So in order to do that, since I'm adding these two together, I always do the opposite operation to solve. So I subtract 81 from both sides. Okay, these guys cancel each other out. So I'm left with B squared. And on this side, let's see, that would be 4 and 14. Okay. So B squared equals 144. But I don't want B squared, I just want B. So how do we do that? Remember, opposite operation. What's the opposite of squaring something? Taking the square root. So once I do that, I get b equals, well, square root of 144 would be 12. So b has to equal 12 centimeters. Not too bad, right? Let's try another one. Oh, I should have put an A next to that one. There we go. Put a little A here. We're going to try another one. This time we're going to be doing something a little different, though. We're going to find the perimeter. Okay, so let's go ahead and draw another right triangle. Again, it does not have to be exact, but use the lines of the book to help you. Okay, something like that. And let's do, let's say this is 8 inches. This is 17.3 inches. And we do not know what this is. That's our unknown. Okay? So, recall how you find perimeter. Perimeter means that you add all the sides of the figure together. But we're missing one of the sides. So before we can actually figure out the perimeter, we need to figure out the missing side. You probably need a calculator for this, so I have mine at the ready, off to the side here. So the first thing I'm going to do is find this missing side. I'm going to label all of my sides here. Since this is opposite my right angle, this has to be my C value, my hypotenuse. I'll call this A, I'll call this B. Now we can go ahead and solve. I'm just going to do it off to the side here. I always rewrite my theorem. And first plug in the values before you solve anything. So A squared, that's 8 squared. We don't know B. And 17.3 squared is my C value. Now we can go ahead and solve each of these. So 8 squared is going to be 64. I don't know my B value yet, so I just rewrite it as B squared. And I'm going to plug in 17.3 into my calculator just to save a little bit of time. 299 and 29 hundredths. Okay. So, I am going to go ahead and solve for this. I need to get B by itself on one side of the equal sign. So 64 has to go first. 0.29, that's 5, 3, and 2. Alright, so B squared, those cancel. B squared equals 235 and 29 hundredths. So, B is being squared here, so I always do the opposite operation. So I take the square root of both sides. That I am going to need to go to my calculator for. I'm going to round to the nearest, I'll round to the nearest tenth. So 235.29, and if I turn this, yep, there's all my different ones, square root. All right, so I get about 15.3. 15.3 inches. Okay, so I have that missing part of my triangle. But what's it asking for? The perimeter. So I'm going to go ahead and add these together. Kind of ran out of room here. I'll just do it off to the side. I'm going to add these together, and then I will know what my perimeter is. So I have 17.3, 15.3, and 8. Add those up. 12 and 8 is 20. And there we go. So the perimeter of this figure is 40 8.6 inches. Very good. All right, we have one more to do, and this is where your cutout is going to come in. Should look something like that, and I'm just going to put a C for this one. All right, I'm going to pause and glue in, and then we will get started on it. All right, here we go. So it says, the bottom of an 18-foot ladder, that's this right here. I'm just going to write it a little bigger because it's kind of hard to see. It says 18 feet. The bottom of an 18-foot ladder is 5 feet away, or 5 feet from the side of a house. Find the distance from the top of the ladder, so right here, to the ground, here. Round to the nearest tenth of a foot. So, you'll notice when I put the ladder up against the house, it forms a right triangle. The ladder makes up my hypotenuse, and the 5 feet away makes up one of my legs. The side of the house where the ladder hits down to the ground is another leg, and that's the one that we are trying to figure out. So, let's go ahead and give this a shot. This is going to be my C value. I'll call this leg my A value, which is the one that I don't know, and I'll call 5 feet my B value. So again, I'm going to go ahead and rewrite my theorem. That's always where I start. Okay? Plug in the values that you know. We don't know A yet. 5 is our B, so 5 squared. And 18 squared for our C value. Don't know A yet. That would be 25, and for 18, I'm just going to pop off over here and do that. 4, carry the 6, 4, put the 0, 8, and 1. All right, 3, 2, 4, I believe is correct. Let me double check. Yep, 3, 2, 4, perfect. 3, 2, and 4. Excellent. All right. So, we need to get A by itself this time on one side of the equal sign. So, in order to do that, 25's got to go. So, I always do the opposite operation. Opposite operation. I get A squared equals 299. Because remember, these guys cancel each other out. I take the square root of both sides. And I'm going to get a long decimal. I'm going to go ahead and plug it into my calculator. Okay. So 299, and we're taking the square root. Ooh, yeah, big long number. It said to round to the nearest tenth, so I'm going to bump that guy up to a 3. So this would be 17.3, and we're dealing with feet? Yes. So from the top of the ladder to the ground should measure approximately 17.3 feet. Alright guys, that's all we have for this lesson today. I'm going to have you pause and head on over to IXL to practice these skills there.